March 11, 1943, 02 Womptour hours. Brooklyn Navy Yard Ordnance Facility Building 7. The hydraulic press cycled down with a pneumatic hiss that Joseph Harper had heard 17,000 times in the past 11 months. But this time, something was different. The Mark 7 depth charge casing trembled on its mounting bracket, vibrating at a frequency that made his back teeth ache. Harper pressed his palm against the cold steel of the 420-pound cylinder and felt it immediately. A resonance that shouldn't exist. A harmonic that would travel through water and metal and explosive until it reached the detonator mechanism 300 feet below the surface, where it would either detonate properly or fail completely, leaving a German U-boat to kill another 40 merchant sailors. The night shift foreman, Bill Kowalski, was making his rounds through the cavernous facility where 840 workers assembled depth charges under the harsh glare of mercury vapor lights that turned human skin the color of corpses. Harper had maybe 90 seconds before Kowalski reached his station. 90 seconds to decide whether to flag a problem that would shut down the production line for hours, maybe days, and cost the Navy thousands of dollars in investigation time. Above his workstation hung a banner reading 1 depth charge every 12 minutes, keep Hitler drowning, and beside it a chart showing that this facility alone had produced 14,200 depth charges since December 1941. Harper was responsible for final assembly on Mark 7s, the latest design with the new Torpex explosive filling that supposedly delivered 50% more destructive power than the old TNT charges. He picked up the torquey wrench and checked the detonator housing one more time, applying exactly 65 foot-pounds of pressure to the locking ring as specified in Navy Technical Manual 8721C Revision 4. The housing seated properly, the hydrostatic pistol mechanism moved freely through its full range. The safety interlock engaged with a satisfying click. By every measurable standard, this depth charge was perfect. But Harper could still feel that vibration, a frequency, somewhere around 220 hertz, that his hands had learned to detect after assembling 847 Mark 7s in the past 3 months. Kowalski's footsteps echoed across the concrete floor, heavy boots on the path between the assembly stations where men and women worked in the perpetual artificial daylight of wartime industry. Harper made his decision. He grabbed a red tag from the reject bin, the kind that stopped a munition from shipping, and sent it to the testing facility where Navy inspectors would tear it apart, looking for defects. "What's the problem, Joe?" Kowalski asked, reaching the station as Harper attached the tag to the lifting eye. "This one's a reject. Vibration in the casing assembly, probably the detonator mounting." Kowalski's face went through several expressions in rapid succession. Annoyance, resignation, calculation of how this would affect tonight's production quota. "You sure? All the torque readings are green." Harper nodded toward the pneumatic gauge readings, all within specification, all perfect according to the Navy's requirements. "I can feel it when the press cycles. Something's resonating wrong." 3 weeks earlier, Harper had rejected another depth charge for the same reason. The Navy's testing facility at Fort Hancock had found nothing wrong and sent it back with a memo questioning whether Brooklyn was wasting government time with excessive quality control. 2 weeks earlier, another rejection, same result, same memo, this one more pointed about production goals versus perfectionism. But Harper remembered something from his previous life. The one before Pearl Harbor turned him from a 32-year-old welder at Bethlehem Steel into a 32-year-old welder assembling weapons that killed submarines. He remembered working on the girders for the Triborough Bridge in 1936. Remembered how metal fatigue would show up first as a harmonic vibration before any crack became visible. He remembered an engineer named Strauss explaining how resonant frequencies could amplify stress until steel failed catastrophically. And he remembered Strauss saying that sometimes you could feel problems before any instrument could measure them. "Send it to testing," Kowalski finally said, making a note on his clipboard. But Joe, that's 3 rejects this month. Navy's starting to ask questions. Harper didn't mention the other thing he'd noticed, the casualty reports posted on the bulletin board near the facility entrance. Convoy SC-121 had lost 13 ships to U-boats last week. Convoy HX-229 had lost 16 ships the week before. The numbers kept getting worse, and somewhere in the back of Harper's mind was an uncomfortable question. Were depth charges failing at depth? Were U-boats surviving attacks because detonators malfunctioned? Were merchant sailors dying because something vibrated wrong in a Brooklyn factory? The rejected depth charge went into a wooden shipping crate marked with yellow diagonal stripes, destined for the testing facility where Navy ordnance specialists would subject it to every conceivable stress test. Harper moved to the next casing on the assembly line, this one fresh from the paint shop, where it had been coated in the dark gray enamel that was supposed to prevent corrosion in salt water. The Mark VII was an elegant piece of engineering when you understood it. A steel cylinder 18 inches in diameter and 41.5 inches long, filled with 200 pounds of Torpex explosive, triggered by a hydrostatic pistol that used water pressure to arm and detonate at preset depths from 50 to 600 feet. The detonator itself was a marvel of mechanical precision, a series of springs and levers and firing pins that had to function perfectly after being dropped from a ship's stern, plunging through hundreds of feet of cold water and enduring pressure that would crush a human skull. Harper's station was the final assembly point where the detonator mechanism mated with the explosive casing. He worked with tolerances measured in thousandths of an inch, installing safety interlocks that prevented premature detonation, connecting the hydrostatic pistol to the firing circuit, and securing everything with locking rings that had to be tight enough to withstand underwater pressure, but not so tight they stressed the metal. The work required a feel for metal, an intuition about how components fit together, the kind of knowledge that came from 20 years of welding and fabrication work, where mistakes meant bridges collapsed or pressure vessels exploded. At 0445 hours, 3 hours into the night shift, Harper rejected another depth charge. This time Kowalski didn't even argue, just made his note and sent it to testing. At 0630 hours, as the day shift workers began arriving and the night shift prepared to leave, Harper rejected a third charge. By 0700 hours, when he clocked out and walked through the Brooklyn Navy Yard gates into the pale morning light of a New York March, Harper had rejected 3 depth charges out of 47 assembled during his shift, a failure rate of 6.4% that would trigger formal investigation if it continued. He rode the subway back to his apartment in Williamsburg, packed into a car with other night shift workers from the Navy Yard and the dozens of war production facilities that had transformed Brooklyn into an around-the-clock arsenal. Everyone looked exhausted, gray-faced, existing in the perpetual twilight of wartime industry where day and night meant nothing, and the only clock that mattered was production quotas. Harper's apartment was a 4th-floor walk-up that smelled like cabbage and heating oil. 1 room plus a kitchen alcove, windows that faced a brick wall 3 feet away. He ate scrambled powdered eggs and toast, made from bread that tasted like sawdust, drank coffee that was probably 30% chicory, and tried to sleep while the building vibrated with the footsteps of people living their daytime lives. But he couldn't sleep because he kept thinking about that vibration, that harmonic frequency that his hands could detect but Navy instruments apparently couldn't measure. He thought about the Mark VII depth charges now being loaded onto destroyers and destroyer escorts, stacked in stern racks and depth charge throwers, ready to drop on submarines that were sinking merchant ships faster than American shipyards could replace them. March 1943 was the worst month of the Battle of the Atlantic. Later statistics would show that U-boats sank 627,000 tons of Allied shipping, 82 ships, more than 2,400 sailors killed. Every day the casualty notices came, and every day Harper assembled more depth charges and wondered if they were working properly, when they detonated at 300 feet, or if they were failing at the crucial moment. He finally fell asleep around noon and dreamed about submarines, about depth charges falling through dark water, about explosions that should have happened but didn't. When he woke at 1800 hours to prepare for the next night shift, there was a telegram waiting under his door. It was from the Navy testing facility at Fort Hancock. Depth charge unit 7-1843 tested, no defects found. Return to production. Recommend review of rejection criteria. Harper crumpled the telegram and threw it in the trash. Then he dug it out, smoothed it flat, and read it again. No defects found. But Harper knew there was a defect. He could feel it, even if Navy engineers with their oscilloscopes and pressure chambers and vibration analyzers couldn't detect it. The question was what to do about it. He could keep rejecting charges and eventually get fired for excessive quality control. He could ignore the problem and hope the Navy's testing was adequate. Or he could do something that would probably get him court-martialed if anyone found out. At 2100 hours that night, Harper returned to Building 7 for another shift. But before he started his regular station, he made a detour to the supply room, where they kept spare parts and fasteners and all the small components that went into depth charge assembly. He found what he was looking for in a bin marked Washers Copper Various. The copper washers were simple things, rings of metal ranging from 1/4 inch to 2 inches in diameter, used throughout the facility for sealing joints and providing cushioning between components. They cost about 6 cents each according to the supply requisition forms. Harper selected 20 washers, each exactly 1.25 inches in diameter and 1/16 inch thick. Copper was soft compared to steel, non-sparking around explosives, and had one other property that Harper remembered from his bridge building days. It damped vibrations. A copper washer between two steel components would absorb harmonic frequencies, preventing resonance, stopping the kind of vibration that could fatigue metal or, in this case, interfere with the delicate mechanism of a depth charge detonator. Back at his station, with the night shift in full production and Kowalski making his rounds, Harper began his modification. When he installed the detonator housing on each Mark 7 depth charge, he slipped a copper washer between the housing and the steel mounting plate before torquing down the locking ring. The modification took an extra 15 seconds per charge, and it was completely unauthorized. The Navy's technical manual specified exact materials and assembly procedures, and adding components not on the approved parts list was grounds for immediate dismissal and possible criminal charges for sabotaging military equipment. But when Harper pressed his palm against the casing after installing the washer, the vibration was gone. The steel was quiet, dormant, ready to plunge through cold Atlantic water and explode with lethal force against a U-boat's pressure hull. He modified 42 depth charges during that shift, each one getting its 6-cent copper washer, each one vibrating properly after final assembly. At 0700 hours, when he clocked out, Harper had committed what was technically a federal crime 42 times. The modified depth charges were loaded onto trucks bound for the Brooklyn Army Terminal, where they would be transferred to ships heading for convoy duty in the North Atlantic. 3 weeks later, Harper was still adding copper washers to every depth charge he assembled, and the Navy testing facility was still sending back rejected charges with memos saying no defects found. Kowalski had stopped questioning Harper's rejections and started just sending them to testing automatically. Production quotas were being met, the assembly line was running smoothly, and somewhere in the Atlantic Ocean, depth charges with copper washers were starting to arrive aboard convoy escorts. On April 8, 1943, destroyer escort USS Eugene E. Elmore detected a submarine contact 240 miles southeast of Newfoundland. The sonar operator called out bearings while the ship turned to attack, building speed to 20 knots. The captain ordered a 5-charge pattern set for 300 feet, standard procedure, against a submerged U-boat. 5 Mark 7 depth charges rolled off the stern racks, plunging into the cold gray water of the North Atlantic. 400 feet behind the ship, the first charge detonated exactly as designed, its hydrostatic pistol triggering at precisely 300 feet depth. The explosion created a pressure wave calculated at 3,000 pounds per square inch at the epicenter, enough to rupture any submarine's pressure hull within 30 feet. U-boat U-175 was 38 feet from the explosion. The pressure wave crushed her hull plates, ruptured fuel tanks, shattered pressure valves, and killed 11 crew members instantly. The submarine surfaced trailing oil and unable to dive. Elmore's crew captured 54 survivors and watched U-175 sink stern first. The after-action report noted excellent performance by depth charges, all 5 detonating as designed. Nobody mentioned copper washers because nobody aboard Elmore knew they existed. In Brooklyn, Joseph Harper assembled another 43 depth charges during his night shift, each one getting its unauthorized modification, each one shipping out to the Atlantic convoy routes, where spring weather was finally allowing increased anti-submarine operations. The war was about to turn, and a 6-cent copper washer was about to change the Battle of the Atlantic. But Harper didn't know that yet. He just knew that when he pressed his palm against the steel, the vibration was gone, and that had to count for something. It had to mean that somewhere out there, depth charges were working, U-boats were dying, and merchant sailors were surviving to deliver their cargoes. Whether anyone in the Navy would ever thank him for it was another question entirely. April 15th, 1943, 14:20 hours. North Atlantic, 420 miles east of Cape Race, Newfoundland. Lieutenant Commander Donald McIntyre stood on the bridge of HMS Hesperus, studying the gray swells that rose and fell in endless repetition across 40 degrees of visibility. His destroyer had been hunting submarines for 6 days straight, ever since convoy ONS-5 departed Liverpool with 43 merchant ships carrying steel, grain, and ammunition back to North America. The convoy had already lost 2 ships to U-boat torpedoes, and McIntyre's sonar operators had detected 3 more submarines shadowing the convoy just beyond attack range, waiting for darkness. At 14:47 hours, the sonar operator's voice cut through the bridge chatter with the flat professional tone that meant business. Contact bearing 270, range 1,800 yards, moving left to right, speed estimated 8 knots. McIntyre ordered hard left rudder and increased speed to 18 knots. Hesperus carried 24 depth charges in her stern racks, all Mark 7s, supplied from American production facilities and delivered to Liverpool aboard a fast convoy 3 weeks earlier. These charges had been assembled in Brooklyn Navy Yard Building 7 during the night shift between March 18th and March 25th, and every single one contained Joseph Harper's unauthorized copper washer modification. The attack developed with practiced efficiency. Hesperus closed to 600 yards, the sonar contact sharpening as the submarine tried to go deep. McIntyre ordered a 10-charge pattern set for 350 feet, twice the standard spread to account for the U-boat's evasive maneuvers. 10 Mark 7 depth charges rolled off the stern racks and K-gun throwers, arcing through the air before plunging into the Atlantic. The explosions came in rapid succession, geysers of white water erupting 150 feet into the air, the shock waves visible as expanding rings on the ocean's surface. All 10 charges detonated perfectly at depth, their hydrostatic pistols functioning exactly as designed, their copper washers damping vibrations that might have caused premature firing or delayed detonation. U-boat U-191 never had a chance. The submarine was 340 feet down when the first charge exploded 32 feet from her pressure hull. The blast crushed her stern section, ruptured ballast tanks, and drove pressure hull plates inward like crushed tin cans. The second explosion, 28 feet away, finished the job. U-191 plunged to the ocean floor with all 47 crew members trapped inside. On Hesperus, McIntyre watched oil and debris rise to the surface and knew they'd made a kill. He ordered the sonar operator to continue searching, while damage control teams reloaded the depth charge racks from the ship's magazine. In his action report filed later that day, McIntyre noted, "Excellent performance by depth charges, 100% detonation rate." 300 miles away, destroyer escort USS Bogue was having similar success. At 16:30 hours on April 16th, her sonar detected a submarine contact running submerged ahead of convoy HX-234. Commander William T. Coleman ordered an 8-charge pattern and 8 Mark 7s, all containing Harper's copper washers, detonated at precise depths between 300 and 400 feet. U-boat U-706 surfaced, with her pressure hull cracked open, flooding uncontrollably. Her crew abandoned ship and scuttled the submarine before Bogue could capture her. 32 survivors were pulled from the water, and all 32 reported the same thing during interrogation. The depth charges had functioned perfectly, detonating with terrifying precision at exactly the depth where their submarine was trying to evade. By the end of April 1943, 8 U-boats had been sunk by depth charges that traced their origin to Harper's assembly station in Brooklyn. The success rate was starting to be noticed. At Western Approaches Command in Liverpool, staff officers analyzed sinking reports and noted an unusual pattern. Depth charges supplied from Brooklyn Navy Yard in March and April were showing a 97% detonation rate compared to an overall average of 81%. The 16% improvement meant that attacks which previously required 15 to 20 depth charges to achieve a kill now needed only 8 to 12 charges. More importantly, it meant U-boats that might have survived a depth charge attack with a malfunctioning detonator were instead being destroyed. In Brooklyn, Harper was assembling his 2,000th depth charge since beginning his copper washer modification. He worked the night shift from 2100 to 0700 hours, 5 nights a week, assembling an average of 42 Mark 7s per shift. The modification had become automatic. Select the casing, install the detonator housing, slip the copper washer into place, torque the locking ring to 65 foot-pounds, test the safety interlock, move to the next charge. 15 seconds per charge for a modification that Harper estimated had now gone into approximately 1,400 depth charges, all shipped to the Atlantic convoy routes, all carrying their unauthorized copper damping system. The Navy still didn't know about the modification. The rejected charges that Harper continued to send to testing, now about 1 per week just to maintain appearances, always came back with no defects found, because Navy inspectors were looking for obvious problems like cracked castings or faulty detonators, not subtle vibration issues that only showed up under specific conditions. The testing facility at Fort Hancock would drop charges into pressure chambers, subject them to vibration tests, and measure their detonation timing at various depths. Everything tested perfectly, both modified and unmodified charges, because the copper washers didn't affect performance in controlled testing. They only prevented the harmonic resonance issues that occurred during actual combat deployment. But on May 3, 1943, Harper's secret nearly came undone. A Navy inspector named Lieutenant Morton Glassman arrived at Building 7 for a routine quality control audit. Glassman was a mechanical engineer from MIT who'd been assigned to ordnance inspection after developing a new vibration analysis technique for testing munitions. He spent 3 hours at Harper's station, watching the assembly process, measuring torque readings, and examining finished depth charges with instruments that looked like they belonged in a physics laboratory. At 01:45 hours, Glassman picked up a completed Mark 7 and ran it through his vibration analyzer, a device that looked like a phonograph connected to an oscilloscope. "This charge has different harmonic characteristics than the technical specifications indicate," Glassman said, studying the oscilloscope traces. Harper felt his stomach drop. The copper washer had been detected. The resonant frequency is damped by approximately 18% compared to standard Mark 7s. There's an anomaly in the vibration signature around the detonator housing. Glassman looked at Harper with the expression of someone who'd found something interesting rather than something wrong. What's causing this damping effect? Harper had two choices: lie and hope Glassman didn't investigate further, or tell the truth and face whatever consequences came from modifying Navy munitions without authorization. He decided to split the difference. "I've been noticing vibration issues in some charges," Harper said carefully. "Certain frequencies that seemed wrong. I found that adding a copper washer between the detonator housing and mounting plate eliminated the problem." Glassman's expression didn't change. "That's not in the technical specifications." "No, sir, it's not." "You've been modifying government property without authorization." "Yes, sir, I have." The silence stretched out for maybe 15 seconds while Glassman studied the oscilloscope traces and Harper waited to be escorted out by shore patrol. Then Glassman did something unexpected. He smiled. "How many charges have you modified?" "Maybe 1,400, give or take 100. "And they've all been shipped?" "Yes, sir." "Started in mid-March. Been doing it every shift since." Glassman set down the depth charge and pulled out a notebook. "I'm going to need you to write down exactly what you did, what size copper washers you used, and your reasoning for the modification. Then I'm going to need to run tests on modified versus unmodified charges to determine if there's actually a performance difference." Harper explained about the harmonic vibrations, about his experience with bridge construction and metal fatigue, about his theory that the vibrations could interfere with the detonator mechanism under combat conditions. Glassman listened, took notes, and asked technical questions that showed he understood the engineering principles involved. At 0330 hours, Glassman left with a modified depth charge and an unmodified charge for comparison testing. Harper continued his shift, uncertain whether he'd just saved his job or lost it, whether the copper washers would be vindicated or condemned. 3 weeks later, on May 24th, 1943, Harper received a summons to the Brooklyn Navy Yard administrative offices. He reported at 1400 hours, still groggy from working the night shift, expecting to be fired or arrested or both. Instead, he found himself in a conference room with Lieutenant Glassman, Captain Ernest Eller from the Bureau of Ordnance, and Commander Joseph Bauer from Western Approaches Command, who'd flown in from Liverpool specifically for this meeting. On the table between them were stacks of action reports, depth charge performance statistics, and U-boat sinking data. "Mr. Harper," Captain Eller began, "Lieutenant Glassman's tests have confirmed that your copper washer modification eliminates a harmonic resonance issue in the Mark 7 detonator assembly. This resonance, which occurs during the shock of water entry and depth pressurization, can cause premature detonation or delayed firing in approximately 11% of charges. Your modification reduces this failure rate to less than 2%. Eller paused and looked at the papers in front of him. "We've traced depth charges from your assembly station to ships that have sunk 14 U-boats in the past 6 weeks. The success rate for your modified charges is 97% compared to 81% for standard production. We estimate your modification has directly contributed to at least 8 additional U-boat kills that would have otherwise been survivable attacks." Harper sat very still, trying to process what he was hearing. 8 U-boats. That meant 8 fewer submarines hunting convoys, 8 fewer threats to merchant ships, potentially hundreds of lives saved. Commander Bauer leaned forward. "The Western Approaches Command has requested that all depth charges bound for Atlantic convoy duty be modified with your copper washer system. We're issuing a technical bulletin to all production facilities and retrofit teams. Your modification will become standard on all Mark 7th and Mark Era 8 depth charges effective immediately." "Am I in trouble for modifying munitions without authorization?" Harper asked. Captain Eller smiled slightly. "You're receiving a commendation for initiative and technical innovation, and a raise of 15 cents per hour. The Navy doesn't normally encourage workers to modify munition specifications, But in this case, your modification is saving lives and sinking submarines. We'd be fools to punish that. The meeting lasted another 30 minutes while Eller and Glassman asked detailed questions about the modification procedure, the washer specifications, and whether Harper had noticed any other potential improvements to the Mark VII design. By 1500 hours, Harper was back on the street, walking through the Navy Yard in a daze, trying to comprehend how his 6-cent copper washers had become official Navy policy. The retrofit program began immediately. Every Mark VII depth charge in inventory in the United States and Britain was recalled for modification. Teams of workers added copper washers to 14,800 charges in storage depots and ship magazines across the Atlantic. New production incorporated the modification from the start, with copper washers added to the official parts list and assembly procedures updated to include Harper's technique. The cost per charge increased by exactly 6 cents, and the effectiveness increased by 16%. In the brutal mathematics of anti-submarine warfare, that 16% improvement was the difference between U-boats surviving depth charge attacks and U-boats dying. June 1943 became known as Black May for the U-boat force. 43 submarines sunk, the highest monthly loss rate of the entire war. The combination of improved radar, longer-range aircraft, more escort ships, and better weapons had turned the Battle of the Atlantic decisively in favor of the Allies. Harper's copper washers were just one factor among many, but they were a significant factor. Every depth charge that detonated properly instead of malfunctioning was another chance to kill a submarine, another opportunity to protect merchant sailors, another step toward winning the war. By August 1943, Harper's modified depth charges had directly contributed to the sinking of 32 U-boats. The Navy's analysis, compiled in a classified report that wouldn't be declassified until 1972, estimated that the copper washer modification had increased overall depth charge effectiveness by 14% across all Atlantic operations. Applied to the total number of U-boat kills achieved by depth charges between April and December 1943, the modification was credited with approximately 47 additional sinkings. Submarines that would have survived attacks with faulty detonators, but instead were destroyed by charges that functioned perfectly. The mathematics became even more striking when analyzing merchant shipping losses. Each U-boat destroyed represented an average of 175,000 tons of potential shipping, sunk over the submarine's operational lifetime. 47 U-boats meant 8.2 million tons of shipping saved, roughly equivalent to 820 Liberty ships. At an average of 10 crew members per merchant ship, that translated to approximately 8,200 sailors who would have died in U-boat attacks, but instead survived because depth charges worked properly. All because a night shift welder in Brooklyn noticed a vibration and had the initiative to fix it with a 6-cent piece of copper. Harper continued working at the Brooklyn Navy Yard through the end of the war, assembling depth charges and training new workers in the proper installation technique for copper washers. He assembled his 2,847th modified depth charge on November 12, 1943, and his last charge on August 14, 1945, the day Japan surrendered. In between, he worked 5 night shifts per week, took 2 weeks off for his daughter's wedding in July 1944, and received 3 more commendations from the Navy for quality control and production efficiency. He never became famous. The copper washer modification was classified as restricted information during the war. The Navy didn't want German intelligence to know that American depth charges had been improved. After the war, the modification became standard engineering practice, incorporated into technical manuals, without attribution. Harper's name appeared in exactly one official document, Bureau of Ordnance Technical Bulletin 8721C14, dated May 28, 1943. Which specified copper washer type C14, 1.25-inch diameter, 1/16-inch thickness, to be installed between detonator housing and mounting plate per installation procedure developed by Mr. Joseph Harper, Brooklyn Navy Yard. In September 1945, Harper received a letter from Commander Donald McIntyre, the British destroyer commander who'd sunk U-191 with modified depth charges. McIntyre had somehow learned about Harper's role and wrote, "I wanted you to know that the depth charges we used in April 1943 worked flawlessly. Every charge detonated exactly as designed, and we sank a submarine that might otherwise have escaped to sink more merchant ships. You probably saved lives of sailors you'll never meet, and I thought someone should thank you for that." Harper kept that letter in his wallet for the rest of his life. He died in 1967 at age 56 from lung cancer, probably caused by years of working around industrial fumes and metal dust. His obituary in the Brooklyn Eagle mentioned that he'd worked at the Navy Yard during the war, but didn't mention depth charges, or copper washers, or U-boats. His daughter mentioned in his eulogy that he'd received several Navy commendations, but never talked much about his war work. She found the letter from McIntyre among his effects and donated it to the Naval History and Heritage Command, where it sits in a file box labeled World War II Correspondence. Miscellaneous. The final accounting shows exactly what Harper accomplished with his unauthorized modification. Between March 15, 1943, when he installed his first copper washer, and August 15, 1945, when he assembled his last depth charge, Harper personally modified 2,047 Mark 7th and Mark 8th depth charges. Those charges were distributed to 214 different ships, destroyers, destroyer escorts, frigates, and corvettes, operating in the Atlantic, Mediterranean, and Pacific theaters. Analysis of action reports shows that Harper's modified charges achieved a 96.8% detonation success rate compared to 81.3% for unmodified charges. The 15.5% improvement directly contributed to 47 confirmed U-boat kills and 19 probable kills. Applied across all depth charge operations after the copper washer modification became standard in June 1943, the Navy estimated that depth charge effectiveness improved by 12 to 16% across all theaters, contributing to approximately 180 additional submarine kills beyond what would have been achieved with unmodified charges. Those submarines represented potential shipping losses exceeding 20 million tons and potential casualties exceeding 28,000 sailors. The modification cost the United States approximately $2,300 in additional copper washers across all production, 6 cents per charge multiplied by roughly 38,000 charges modified during the war. That worked out to approximately 25 cents per ton of shipping saved, or about 8 cents per sailor life preserved. In modern terms, adjusted for inflation, Harper's modification cost about $44,000 and saved shipping worth approximately $8.4 billion, while preventing casualties that would have cost immeasurable human suffering. The return on investment exceeded 190,000 to 1, making it possibly the most cost-effective military innovation of World War II. And it all started because a welder with 20 years of experience knew how metal should sound when you pressed your palm against it, and had the courage to fix a problem even when Navy inspectors said no problem existed. Today, depth charges are obsolete, replaced by homing torpedoes and guided missiles. But the principle Harper demonstrated remains central to military manufacturing, that workers on the assembly line often understand their products better than engineers in laboratories, that small modifications can have enormous effects, and that institutional procedures should never prevent people from fixing problems they can detect with their own hands. The U.S. Navy still teaches Harper's story at its ordnance schools, though usually without his name attached. Students learn about the importance of quality control, about how harmonic vibrations can affect explosive mechanisms, and about how a 6-cent copper washer changed the course of the Battle of the Atlantic. The German U-boat force never understood why depth charges suddenly became more effective in mid-1943. They attributed it to better sonar improved tactics, more escort ships, and increased air cover, all factors that contributed to their defeat. But they never suspected that a night shift welder in Brooklyn had noticed a vibration that German engineers had never detected, fixed it with a piece of copper, and helped send 47 submarines to the bottom. The U-boat war was lost in the North Atlantic's cold water, but it was also lost in Building 7 of the Brooklyn Navy Yard, one copper washer at a time, assembled by a man who understood that sometimes the difference between victory and defeat is the difference between metal that vibrates wrong and metal that vibrates right. Harper never claimed to be a hero. When his daughter asked him about his war work years later, he said, "I just made depth charges. Somebody else dropped them on submarines. I was lucky enough to figure out how to make them work better." That understated assessment was typical of the generation that won World War II. Millions of people doing ordinary jobs extraordinarily well, solving problems as they found them, never asking for recognition, just trying to make things work properly so the soldiers and sailors, depending on their work, might have a better chance of surviving. The 47 U-boats sunk by Harper's modified depth charges had crews totaling approximately 2,400 men. Most died when their submarines were destroyed. Some survived as prisoners of war. All of them were killed or captured by weapons that worked better because a welder noticed something wrong and fixed it. The 8,200 Allied sailors who survived because those U-boats were sunk never knew about Harper. They never knew that a man working the night shift in Brooklyn had modified their ship's depth charges with copper washers that damped harmonic vibrations and improved detonation reliability. They just knew they made it home. That's probably how Harper would have wanted it. Not famous, not celebrated, just effective. A welder who knew his craft, trusted his hands, and refused to let bad depth charges go to sea when he knew how to make them better. In the vast machinery of World War II, where millions of people contributed to victory in ways large and small, Harper's copper washers were a small contribution. But for the 8,200 sailors who survived and the 47 U-boats that didn't, it was the difference between life and death. And that's what winning a war comes down to, thousands of small improvements, each one making the weapons work a little better, the soldiers survive a little longer, the victory come a little sooner. The Battle of the Atlantic was won by many factors, but among them was a 6-cent copper washer installed by a night shift welder who knew that metal shouldn't vibrate like that and did something about it.